everybody. Welcome back to CodeChat. I'm going to be talking with Rick Barraza today, and we're going to be talking about AI or machine learning or whatever you want to call it. Yeah. We're going to be talking about some of those concepts. So a couple weeks ago, I kind of renewed or revived CodeChat, and I told you that there are a few technologies that I am really deep in, interested in, moving in. Things like IoT and a little bit of bots, and there were a couple of technologies that I told you that I'm really excited about. I know that they are hugely impactful in the digital world in computer science, and one of them was machine learning. Another one was blockchain, and so I'm excited to have this conversation today with Rick because Rick is a real visionary and well-spoken. He understands a lot of concepts and does a good job of relaying those. And you're working right now, Rick, in the area of AI, right?
Yeah. So I've been helping out. Well, I'm in evangelism, and I've had a big focus on AI, but specifically deep learning.
Okay.
So there are a lot of these buzzwords going around. There's AI, and then ML, and then deep learning. And sometimes I think even at the where to start, I think giving a nice vocabulary is good.
That's a good idea.
So we're all on the same page, because where does it fit in? Bot frame is associated. Cognitive services is associated, right? Is this AI? Is this ML? Is it DL? As a very quick level set, is that fine? So AI has been going on for a very, very long time. As we know, 1956, Dartmouth College. And that was basically, can we have computers do things that if humans did them, it would be deemed intelligent. And that seems like a weird definition now because we're so used to computers just being smart for us. But if you saw like Hidden Figures, the movie Hidden Figures.
I didn't.
Oh, you have to watch it. It's a fantastic, like after this is over, let's go watch it right now. So it's about the human computers. They were women, and most of them were people of color. They were working at NASA, and they were human computers. This was in the 50s. We know in World War II, human computers. But the whole point, the challenge was that she was a woman, she was a person of color, she was also a computer. And so she had ideas she wanted to contribute. But the culture was that, no, the male engineers are the ones who do the problem solving. A computer's job is just to crunch numbers. So that's kind of the way we've thought about computers. Even when they became digital, for a very long time, computers just crunch numbers. AI broadly was the different approach to that. Say, no, let's see if we can make computers be smart, do things that we would consider smart, not just be number crunchers for humans. For a long time, we did this with if statements. I know in the 80s, right, we thought, well, we could pre-program every possible scenario with a lot of, and we'd call these expert systems.
I think that's how ELIZA was created, right?
Yes, exactly.
Lots of if statements.
Just a whole bunch of if statements. And it's funny now, we look back at it. But I think with myself, even growing up, once you learn the power of if statements when you're very young, it's like, oh, I can code anything, right, with just if statements.
And now the way I understand it, I've always said that if there's a system that I've engineered from start to finish, then it cannot be any bigger than me. It's very imperative, and I've walked it along the way. And what I've always wanted to do, I love the movie A Beautiful Mind.
Yes.
Because what he was looking into was this emergent behavior, these systems that kind of escape the designer, where you create something and then it just kind of lets go. And so that's what we're talking about.
Yeah, exactly. So once we went down the if statements route, the world started getting more complex, and data got more complex, and a lot of people started realizing, you know what, exactly to your point, maybe we can make software that's bigger than ourselves. And this industry, this subsection of AI was called machine learning. Now, machine learning has, again, in its subsection definition, software that if you program it to do a task, will get better at that task the more you use it.
So that's the general definition of machine learning.
Yes.
It'll get better at what it does.
Exactly.
Awesome.
Now, it doesn't have to be a neural net, right? We have genetic algorithms. There are a lot of different ways you can do this. But at a high level, and looking at it from history, if you wrote the software from start to finish, like you were saying, and it can't get bigger than you, then it's not machine learning. If you do anything, you maintain a buffer, you provide some feedback, you have it do a task, and then there's feedback how wrong it is, and it updates itself. That's the direction of machine learning. So if you now, what was interesting, that's what drove a lot with the web. Whenever you're getting email and it says, well, is this an inbox or is this spam? That's machine learning in practice. Machine learning became very, very powerful the past 20 years or so, especially with the web, because there's so much data moving around. These types of systems that got better the more you used it, really started improving. So machine learning has been here for a while. It's been very popular, but it was also very specialized. Mm-hmm. I know you and I, we're more general computer programming. We like different things, but this kind of industry of data science and big data and machine learning, it's a very specialized type of community. At a certain point, and over the years, they've developed their own culture and their own buzzwords and their own way of thinking about problem solving. They write code, but the culture is a little bit different. What happened recently, and by recently I mean like 2012 or so, is deep learning kind of blew up and has taken over, has been the main thing that's attracted so much buzz.
Now, I've heard deep learning and machine learning used interchangeably, but you're saying that deep learning is a specialization of machine learning.
Yes, absolutely. So for example, with machine learning, I can set up linear regressions. I can, there's tricks you can do in your software to make them get better. You're not necessarily building a neural net, but all of those things count as machine learning. If I go to Azure ML, then that's a place for anybody who's data science, any machine learning, all of those decades of classical machine learning ways of doing things, those are all up there on Azure ML. I can bring in data and I can slice it and dice it using all of the established tricks we have.
Okay.
Deep learning, to explain it more like a story, right? If machine learning was trying to solve the problem of transportation, and we as computer programmers, no offense, but we like horses and carriages, like that's the world that we live in. We use code to build carriages, and then we use computation as the horses and we drive it forward. Machine learning and AI was trying to solve this problem of transportation. And so they were building cars. There's always been this group, since the 1950s, Rosenblatt's perceptron, there's always been this minor little fringe group within this bigger industry of machine learning that were pushing this idea of neural nets since the 50s, since AI's been around, since a little bit after computers, right? We're talking Turing. This little group was saying, hey, I know everybody else is trying to solve the problem of transportation by building cars. Let's build synthetic horses, right? I mean, it's such a bizarre idea, right? Well, no, cars are better. It's easier. And they're like, well, let's build some, let's look at how the human brain works and let's use that to inspire how we're going to set up this. Neural nets have always been an appealing idea. They just didn't work. And people would come in and they'd hit their nuclear winter, say, okay, we can't do neural nets that way, so we'd go back to if statements. We'd go farther on again in the late 80s, right, and early 90s. Let's do neural nets. Well, no, we have machine learning that we can solve it without this extra burden of trying to set up software that mimics the brain. That's ridiculous if just regular software, regular programming does it, right? So they kept working at this problem for decades, and it needed a couple things to be resolved. Around 2012, all those pieces started falling together. And at 2012, there was a special event. It was called ResNet, and AlexNet came out. And the results of this were just unimaginable. It outperformed even classical machine learning just ridiculously. It destroyed everybody in this competition. And at that point, it was kind of the shot heard around the world that after decades and decades and decades, neural nets have been able to become deep neural nets. We have enough data. We have enough, the algorithms have finally been optimized. We have enough big compute and with the cloud that we've finally been able to turn on this particular type of engine. So if machine learning was almost building car engines, right? Deep learning was like building airline, just massive engines. We just didn't have enough fuel. We didn't have big enough horsepower. All of that stuff finally fell into place around 2012, 2013. And that's why we've seen this explosion of deep learning-led features. Now, deep learning technically is a subset of machine learning, and a lot of machine learning is applied toward AI. But deep learning is a thing that kind of woke up everybody's imagination. Before 2012, we had books on machine learning, and machine learning was important. Microsoft's always been a very world-renowned center for classical machine learning, right? Google, a lot of the competitive landscape. This has been one of the biggest differentiators was machine learning. But deep learning is something net new. Neural nets have kindly been viable. They've exploded out in power, and it's really what's attracted so much attention. They're really, really good at vision and at natural language, and that's why those two things. Since 2012, we've seen explode out, not just Microsoft, in the entire world of computation, right? This deep learning, I like to say, tilted the vector of progress that classical machine learning was on. 2012 came, and things just started shooting up this way, right? Among everybody.
So what I want to do today, Rick, is I want our audience, who in our audience we've got a lot of developers. You know, they're classic computer science. They're working with, you know, trying to do their own internal combustion, you know, and climbing on top of these various systems. And now machine learning is a thing. The deep neural networks are a thing, but it feels really imposing and intimidating. I want them to know, first of all, that it's significant, that this is not only a, I want them to understand that this is not one of those concerns like gaming where they can just kind of choose to avoid it. They kind of are going
TVs.
to have to, they're going to have to face the prospect of learning some machine learning in their jobs. But then I also want my audience to not be intimidated by machine learning. I want them to know that it's accessible, that it's something that they can learn. So talk to me about the accessibility of machine learning, because when it's new, we see it in its specialized form in these large applications. Like we see this huge data set, and some massive company with deep pockets is talking about how they studied it with machine learning and they figured out this result. But what about my developer who's working on a text box in his website and he needs to use a little bit of machine learning to figure out what to fill that text box with? What about these little applications? How accessible is machine learning?
So there are like 5 different questions in that one question. So let me try and break them down. Let's focus on the last one. So there are enough services out there that you could start using deep learning without and I'm saying specific deep learning, but using machine learning, this new power. Because even all of our cognitive services, not all of them necessarily use deep learning. A lot of them are still using tried and true machine learning algorithms, right? So getting into the weeds of which one it's actually using sometimes may not be necessary, right? If you fall in love with this topic, which I did, and you kind of change your career vector to just be all in on this, it's very, very rewarding. It is intimidating if you feel that, it is intimidating if you're really trying to understand it, and you realize, wow, this isn't like learning blockchain or learning REST call. You know, this is a different thing. This is an entire industry, different buzzwords. So it's only intimidating if you're applying the expectations of how quickly you're used to picking up stuff. It's like, okay, this is a different field, right? It's accessible, obviously, but you have to almost approach it with a certain humility. If you do approach it with a humility and you're bright, you'll be able to get it, no problem. But sometimes I've seen people crash against it because they're used to being really smart with computers. This is computers, and all of a sudden it feels different. And some people don't like that, right? If you can get past that, it's very accessible. It is accessible. Your question of how to just start using it if you have a text box, this comes into like REST APIs, this comes into cognitive services, all of these features that kind of say, look, if you don't want to understand it, it's a magic black box. And if you send us some information, we will do our AI magic and give you back a result, and we're going to make REST APIs, and you can plug and play. That is a way of learning it, where I have something, I know that these cognitive services allow me to do certain things, like Lewis is really good. Okay, I want to bring in natural language processing. I want to do text-to-speech, speech-to-text. I want to take pictures and have it read, do character recognition. I can play with it that way, like just plugging in little samples. And that's good. We support a lot of that. That's kind of the easiest way of doing it. One challenge with that, one caveat. The reason I'd kind of, as developers, of course, start there. Like spend an afternoon and you got it. It's REST APIs. You got it. Keep a running tally in your head or the galleries of what it can do, and that's fine. And just treat AI like a big collection of magic black box services. That at least gets you in the water. That's not my focus when I talk to people. A lot of other people already have that angle covered, right? A lot of research, a lot of evangelism, a lot of videos go in that angle. That's not my particular focus. The reason it's not is because I think back, let's say it was the 1988, 1989, 1990, and you were already a really good programmer, because most people watching your show, it's not like, we're already programmers.
They're not new to this.
They're not new to this. We do this for a
We've
living.
done a REST call or two.
Yes, right. If we had this mindset in 1989, 1990, we're good at our jobs, you know, we rock and roll. Somebody comes up, maybe a young person or somebody from research, and say, hey, there's this thing coming up called the internet. We'd be like, wait, what's this? Computers talking to each other? Yeah, I've been doing that for a decade. Mm-hmm. You know what's going to be great is that I will no longer need to burn my executables onto a disk and mail them a disk. I'll be able to use the power of the internet so they can download the executables. I get it. I understand the internet. I understand how I'm going to use it. I've already been doing it for years anyways. Computers talking to each other. I'm ready to rock and roll. Mm-hmm. And they will completely miss what happened in the 90s because the true power of the internet wasn't just about connecting the computers to send executables back and forth. It was to move computation up to the cloud, right? That big picture, they'd completely miss it if they were just thinking of, you know, in this, how do I pragmatically get this little nugget and plug it in and keep rolling without stopping and thinking. Computation is changing, is broadening out. What I do is still true, but the playing field has gotten bigger. I feel with AI, we're at the exact same spot where many people who are really good at classical computer programming are hearing AI. They start, you buy a book, and it's like all math, and it seems ridiculous, right? You're doing all these things. It seems a little intimidating. You don't have time for that level of investment. So it's like, okay, wait, what can it do? Okay, so I can plug it in for this and plug it in for this, and then they just keep rocking and roll. I get it.
Great.
And they're going to miss, I believe, in my opinion, the complete transformation that AI is bringing to computation, of we do things. Not that just like in the 80s, you can still write desktop software. The cloud didn't take that away, but it completely changed the playing field. AI is now coming in and changed the playing field, in my opinion, even more significantly.
So you're saying to developers, you're encouraging them not to miss the impact, not to overlook the concepts that are behind this revolution and just see, oh, great, now you can look at a picture and see what's in it, or now you can turn text to speech or speech to text. Great, it's a new function, it's a new feature, I can call it and I can use it, but rather step back, look at the concepts and what?
Look at the concept. Yes, to grok the implications. Again, it might not change anything in your life, and you might still, and it'll be great. Hey, I have this black box. My bag of tricks has gotten more broad, and it's powered by AI on some of these fringe things, and that's fine, especially if you do this and this is your job, and you don't want to change in careers.
Yeah.
But a new Wild West has opened up, and for some people, it will be worth the time and investment and change in the way we think and change how we approach computers to move into this new Wild West. I'm trying to make that accessible to a lot of people because I think the broad implications of what's going on, if it was presented properly, I think enough people would get the big picture. Aha, I get it. Now it's going to be worth me jumping into it. And I don't think AI has really been presented that way enough right now. It's being presented, you either need to start at the base of the mountain of machine learning and work from scratch all the way up, and that's very intimidating, right? Or just think about it like a collection of black box services and plug it into your workflow, and nobody's trying to make you scared. It's the middle sweet spot that I'm trying to cultivate. It says, look, you don't have to learn the entirety of machine learning just to start playing with AI, with deep learning right now. CNTK, TensorFlow, there are a lot of things out there that we're bringing in and supporting where you can start playing with it right now without needing to go all the way up. Right? There are abstraction libraries. You're not alone. There are a lot of people who didn't come from deep machine learning who are now having a lot of fun and building their own AIs now.
It does seem to me like there's everything from the very difficult way to do machine learning to the very, very easy way to do machine learning, and you can jump in and pick any point that you want. One of the things that sometimes I get concerned with is when technologies are somewhat nascent, there's a lot of churn. They're changing every day. There's new things that come out that completely change the paradigm, let alone the actual method for doing something. And I tend to wait for the churn to settle down a little bit, and except for in a couple areas where I have time to kind of be involved in the whole community coming up to speed on it. But in a lot of areas, I like to wait for the churn to settle down and then say, now is a good time for me to learn this technology. So in your opinion, is now a good time to learn machine learning, or is it better to wait for the churn to settle down?
I think that's a personal question, right? Because there are some things that I have to believe you don't wait for the churn to settle down. There's always one or two things in your life that you're going to be at the bleeding edge, and everything else you're going to wait for the churn to settle down,
that's
right? So for me, AI and deep learning is the thing. I think it is the most significant thing. I want to be in the churn right now because I want to be influencing the churn and contributing to the churn because we don't have the answers yet. We're not even asking the right questions yet on a lot of this stuff. So the churn is actually what's most appealing right now, right? This is mobile in 2008. This is the internet, 94, right? This is, it's not easy, and that's a good thing right now. This is where the opportunity is, and to really be a part of this, to shoot up very, very quickly. Once the churn settles down, right? You're not.
It's going to be more commodity.
Yes, it will be a commodity. So that's fine. So for me, right now is the best time to do it. The challenge, because it is still the Wild West, and the Wild West is kind of like the great neutralizer. It didn't matter what you did before, right? The fastest sign, the fastest gun becomes the sheriff.
That's right.
So it's the great neutralizer right now, AI, and it appeals to a certain type of personality. And some people that might not have been good with certain types of classical computer science problems actually are intuitively good at AI because it's a different way of thinking. I'd like to briefly explain how it's different.
Okay,
Is that okay?
Sure.
So, and this might help for people to see the big picture. Under classical programming, we as the developers would create the secret sauce. A customer would come in and have a problem. They would give us inputs of some sort. We can consider those inputs X. We as the developers, and they would say what they want to pay us for. These are the results I want are Y. Right? If I give you these inputs X, I want you to give me the Ys. And so we would create the secret sauce, and we'd consider those secret sauce, or we call them weights, right? The W. So the equation of what classical software has always been is our customers give us X, we come up with the W, the weights, and our software generates the Y, the output that they're going to pay us for. This is how it's been. Our ego as people, as developers, has been we are smart enough to create that secret sauce. We create W.
We make W.
Yeah, we make W, right? Muggles don't. And we're wizards and we create W. That's classical programming. If you can do it that way, do it that way. Because classical programming gives you a definitive answer based on our secret sauce, right? Y is accurate. Y is either right or it's wrong. But baked into that is the assumption that we are smart enough to create W. There's an entire universe of problems out there that are just too hard for us as humans with human intelligence to create W for. And so as computer programmers, we don't like those types of problems, so we kind of slice it and dice it a different way. But that's been implicit. This world of classical programming exists in a world where we as humans are smart enough to solve those problems, and all the other problems, well, we just pretend they're not there. When we think about it this way, AI begins where classical programming ends. For all the problems that we were not smart enough to create W, AI comes in and says, as long as you have data, lots of data, of previous versions of X and Y, I will churn through that data, the AI, and the AI will grow a W that finds the correlation between X and Y. Now, for some programmers, and I've met some, and they're brilliant, brilliant programmers, and they're doctors, of computer science, they don't like that intuitively. It's not science anymore because our job has always been about causation. We're finding the causation that gets you from X to Y. And AI is totally different. It's just correlation. It might not even be accurate, but it's mapping the data. So if we think about it this way.
And the answer is like 0.79 probability
as opposed
to 1 or 0.
But again, as opposed to totally, I don't know, which is where many times we'd be stuck with.
That's
so if we think about it like this, and I like to think of classical programming as being the land animals. We were the dominant land, the apex predator, right? We were the dominant species on land of classical programming. We're really, really good at that. And we can augment it with things like blockchain, distributed computing, all these other tips and tricks. We dominate the land. AI begins now where classical programming ends, and it gives us the ability of kind of moving into a higher strata that we weren't able to do before. So they don't necessarily compete with each other. AI always comes with this probability and statistics, and I'm not really sure, but based on the data, here's my prediction, and we can reduce the error, but it's still predictions. If you can solve the problem the classical way of computer science, do that. You're getting causation, right?
Yeah, right.
AI begins where classical programming ends, and it has just given us a new dimension of computation. And I think that's what's going to change, is now we're filling up the volume of problem space.
It seems to me like less of an invention and more of a discovery, because when you see the kinds of problems that are solved with a good machine learning application, the data was there. It was just sitting there with the answers in it, or the answers to the degree that we're capable of pulling the answers out. I used to work in aerospace manufacturing and did the application of machine learning, and we would look at the manufacturing variables, and sometimes they would be 80 to 300 variables, a whole bunch of variables, and then a whole bunch of records, right? All this data, lots of good data. And the result was whether or not the part that was being created was good or bad, or it had to be reworked. And they would oftentimes have multiple black belts in the room looking at this data, trying to chunk it up into small sets at a time, because they're trying to see the patterns. They're trying to see the forest for the trees. And the fact is that humans are just really, really terrible at looking at more than about 3 variables at a time. And then when we would crunch it, and it would come out and say, well, it looks to us like every time this and this and this and this and this variable are set like this, you end up with a bad part. And it's a discovery. Then they go, we didn't notice that. We had no visibility to that. But it brought out something that already existed in the data. The pattern was there. We have the information that says what makes bad parts. We just haven't been able to put it together until now. So
I agree with everything you're saying, but I would push that into the domain of classical machine learning. Everything you're saying. So classical machine learning is just finding the patterns that were in the data.
Yeah, okay.
AI, as like table stakes, yes, does that, but does it better usually. But what it's doing, the difference between classical machine learning, which is what most of us were exposed to, unless you just got into this after 2012, specifically on deep learning, you want to buy a book on AI and you order something on machine learning because everybody's using the same phrases. You go through all of these books, they didn't even talk about deep neural nets, right? It's just all this other stuff. And that's always been exactly like you described it, perfect. Deep learning, and the reason the vector tilted, is it took all of that and it weaponized that math into an engine that can crank and turn itself and not only find patterns but generate original content. And that's the area where I'm focused on in synthetic creativity, because I focus quite a bit on creative stuff, as you know, in arts. If we continue the metaphor of the equation, right, where classical software was X, we create the W and the Y is generated. Machine learning broadly has been give us a lot of X and Y and our software will generate the W.
Right.
Deep learning allows us to take it one more crank, because once those W's are set up, we can now start creating these weights so well that we can take W and existing outputs and generate new X's. And again, classical programming, we create the W. Machine learning, we give it X and Y and it generates the W. This next turn of synthetic creativity, we're giving it we've trained AIs with a W, we're giving it existing Ys, and it's creating original X's from scratch. As a simple example, it's easy now in 2017 to send a picture to a black box service, and it says, okay, that's a person riding a bike. It's been almost impossible to unscramble that egg, though, to tell an AI, give me a picture of a pink octopus playing a keyboard wearing a hat. And it generates the picture back, right? Going the opposite way is significantly harder than turn this picture into natural language, turn natural language into a picture that has never existed before. That's what we start getting into the area of synthetic creativity. Now with things like generative adversarial networks, with cycle GANs that are going on, a lot of these are on my GitHub repo as well, projects that we've been doing. It's this area that classical machine learning just can't even touch that. I mean, your description of classical machine learning was spot on, right? It was finding those patterns hidden in the data. Deep learning takes that, weaponizes it, turns it into an engine that you can run for itself and that can start generating original X's out into the world. And that is the thing that just has me like terrified and fascinated every single day.
That's good to know, because now that you put it that way, the way I'm visualizing it now is a robot armed with classical machine learning, capable of looking at the world around it and quantifying it, making sense of it.
Yes.
But a robot armed with the new phase, the new order, with a deep neural network capability, able not only to make sense of the real world, but to become a producer.
Yes.
But to come up with something.
Yeah. And that's fascinating.
Yeah, it is.
And that's very early on. It's the churn, but that was science fiction. That's been science fiction for millennia.
Yeah.
And we're at the point that it's becoming possible. We're having repos, there's experimentations on this. We're running Hackfest with some very forward-leaning partners already on this third turn of the crank of generative, of synthetic creativity, synthetic content. I'm spending all my time on that because it's just absolutely fascinating. And it's a very niche part of it. I try and speak broadly, like with this interview on AI for everybody. I believe we need a diversity of minds and personalities. There's a problem. I think last time we spoke, and I think to wrap things up, there's a problem that happens in AI. It's called overfitting. And it's what happens when you build a neural net and you build the neural net too smart. It's too smart at crunching data, but you don't give it enough diversity of data. It doesn't learn the pattern, just memorizes the inputs, right? Which is funny when you like, oh, I've created a brain to understand the data. The brain just memorized. You made it too smart. It memorized a small set of data. That's called overfitting. It seems to work during training, and then you put it in the real world, and it doesn't know how to interact with it. We have a challenge right now, and we globally, right, with AI, is we have a lot of smart people on it, but they're just talking to the same type of classical machine learning and people who had kind of been in this career path. I feel that a lot of the conversations around AI are a bit overfitting to certain types of people. And if you come in as an engineer, someone who likes something different, as an artist, as anybody who just, as a maker, as a hacker, coming in, they're not getting enough of that diversity in. And so there's a lot of overfitting in terms of how we explain it and how we evangelize it. That's one of the areas that I'm trying to push back because I'm really passionate about. AI's for everybody. Like, it exists now. You can, like a car, like the car exists. We can teach how to drive. We can fall in love with driving. You don't need to build the car from scratch anymore. Cars exist, right? You can take the bus, you can do cognitive services, right? You can have somebody else do all the driving for you, and you can take advantage of this new miracle. But cars now exist. You don't have to start from building an engine. You can just start rocking and rolling and driving and fall in love with driving, right? Be a good driver, learn how to fix it. So it's this kind of approach in the middle that I've been focusing on.
That was totally meta, Rick. You just used machine learning to describe developers entering the world of machine learning.
There you go. Okay, I guess that's true. There you go.
Something like that. Okay, well, yeah, let's go ahead and wrap it up. I hope that this was helpful to you guys, just learning about what this world looks like, how it's going to impact you as day-to-day developers doing computer science, but adopting some of the concepts or maybe all of the concepts of data science. That's going to be a pretty interesting world going forward. I always say this is a good time to be a developer, no more than ever. So anyway, thank you, Rick, for being with us.
Thank you for having me here.
Yeah, and we'll see you next time on CodeChat.